So we are here to direct you. We are here to teach you on what to do, and you go ahead to do it. I'm sure my senior colleague must have done uh, justice to the course, and I'm here to handle these topics: code generation and optimization, error detection and recovery in compiler, automatic garbage collection, static and runtime data representation, storage allocation, and register allocation. Are you hearing me?
I can
Hello?
hear you.
I don't know. Do we still? Oh, good.
We have to go on.
Okay. Now, during compiler construction, I'm sure she must have told you the stages in compilation. And you all know that when you write programs in other higher level languages, they need to be converted or translated to machine readable codes. And we have translators such as compilers, interpreters, and assemblers. Assemblers convert or translate programs written in assembly language to machine codes, while interpreters and compilers translate programs written in high-level languages to machine language. So now we are talking about compilers and compilation. And during compilation, there are stages. There are stages in compilation. We have when the source code that will pass through what we call lexical analysis. I'm sure she must have handled you on those areas. Lexical analysis. From lexical analysis, you now have a syntax analysis. From syntax analysis, you go to a semantic analysis. From semantic analysis, you now go to code uh, uh, generation and optimization, and it continues until you get your target program. Who joined now?
Choma Obeta.
Okay, Joma, why are you joining late?
Maybe she didn't come close on time from her workplace.
Okay, so we continue, please. So I'm supposed to handle code generation and optimization, error detection and recovery in compiler, automatic garbage collection, static and runtime data representation, storage allocation, and register allocation. So let me just pick them. I've decided to give a summary of the whole thing. Then at the end of the day, I'll be posting to you the materials that I've gathered together. So you read it and prepare your questions. Now, let's go to code generation and optimization. Of course, we know that it takes this stage, after the semantic analysis. Now, remember, you know the difference between syntax analysis and semantic analysis. Semantic has to do with the meaning of the language, while syntax has to do with the lexical part of the language. So when it is done from these stages, you now go to code generation and optimization. Now, this intermediate code, the code generation and optimization takes intermediate code as the input. Then the target code must preserve the meaning of source code and should be of high quality. So when we look at optimization is prior to code generation. Optimization is prior to code generation. So code generator that means immediately after code generation, we now go to what? Optimization. So code generator has three primary tasks. The first task is The first task is instruction selection. Instruction selection simply means choosing appropriate target machine instructions to implement the intermediate code representation statements. Then after the instruction selection, we now go to register allocation and assignment. Then after that, this one decides what values to keep in which registers. Has to do with register allocation. Which values or which values do you keep in registers? Remember, register is a an example or a part of the memory where values are kept, maybe during a computation. So we have register, instruction selection, register allocation and assignment, and the third one is instruction ordering. This one decides what order to schedule the execution of instructions. Then after that, we now go to what we call, there are different issues in code generation. Remember, we'll talk about code generation before we talk about optimization. There are issues we need to consider under code generation. There are issues we need to consider under code generation. The first issue there is input to code generator. What is the input to code generator? Remember, I've said it before that the input to code generator is the intermediate representation along with symbol, table, information that is used to determine runtime address of data objects denoted by the name intermediate representation. Each time you see IR, is an acronym for intermediate representation. There are many choices for IR. They include 3 address representation, which has to do with quadruples, triples, and indirect triples. We have virtual machine representation, which has to do with byte codes and stack machine codes. We also have linear representations. This one includes the postfix notations. Then we also have the graphical representations. This one has to do with syntax trees. Then we've talked about the input to the code generator. Another thing that is crucial here in code generation is the target program. We have talked about the input. Then this one is the target program, which will now take maybe as the output from the code generation stage. Then under the target program, we have that the instruction set architecture has significant impact on constructing good code generator for producing high quality machine code. Most common architectures are the RISC, RISC, it's an acronym, and CISC, CISC. These are the most common architectures we have. Then the RISC, which is an acronym for Reduced Instruction Set Computer. This one has many registers. It has 3 address instructions. It has simple addressing mode and simple instruction set. Then the CISC architecture, which is CISC is an acronym for Complex Instruction Set Computer. It has few registers, 2 address instructions, variety of addressing modes, several register classes, and variable length instructions. You can see the difference between the RISC and the CISC. Then we have the target code also are produced in 3 forms. Target code produced can be in 3 forms. One is what we call absolute machine language. Absolute machine language. The second one is relocatable machine language. Relocatable machine language. And the third one is the assembly language programs. So we now talk about another issue we need to talk about under code generation is the instruction selection. After this instruction selection, we'll now talk about the memory management. Memory management. Then the fifth one is the register allocation. A key problem in code generation is deciding what values to hold in what registers. Remember, I said before that register is a part of a memory or a type of a memory where data are kept or values are kept during code generation and optimization. So registers are the fastest, but they do not have enough of them. They don't just contain much. It's just a temporary uh, avenue, a temporary, memory to store data for that particular purpose. So they are not really, they don't have enough space in them, but they are very fast. Efficient utilization of registers is particularly important. The use of registers is divided into two sub problems. The use of registers is divided into two sub problems. We have the register allocation and the register assignment. When we talk about allocation, we're actually talking about, selecting the set of variables that will reside in the register at each point in the program. That one has to do with register allocation. Then the register assignment simply means how we can pick the specific register that a variable will reside in. That is assigning a register to a particular variable in the program. So the two sub-problems under the use of registers are register allocation and register assignment. Then we have the last one is the evaluation order. The evaluation order. Some computation orders require fewer registers to hold intermediate results than others. So you need to find out the order in any particular computation you are using. Then picking the best order in the general case is a difficult NP complete problem. Now we go to error detection and recovery in computer. Remember, I just give you the summary of each so that when I send the material, you can sit down and read those ones. Then in error detection and recovery, these are the two things. You have to detect an error and you also recover from the error. And it is an important role of the compiler to actually report any error in the source program that it detects during the entire translation process. When we are talking about the stages in compilation, each of these stages has its own error detection and recovery. Each of them has, that we have what we call lexical errors. During lexical analysis, we must encounter some lexical errors. For example, when you assuming somebody wants to type print, somebody wants to type print, instead of typing print, the person will now type prnit. It is a lexical error. So at that stage, that error will be detected and the compiler will do something about it. So that is it. The error, reporting an error is a very crucial part of compilation. Now, each phases of the compiler encounter errors, as I've said. After detecting errors, those errors must be corrected to precede compilation process. Any error encountered must be corrected. Then you move on in the compilation process. So the syntax and semantic phases handle large number of errors in compilation process. Remember, I've given you an example of a syntax error. You could also have semantic error. This one has to do with meaning. For example, we know that Emeka is always a male folk. You understand? And you can, if Emeka is a male individual, it then means that if you say that Emeka is a girl, then it's going to alter the meaning of that statement, meaning that semantically that statement is wrong, but syntactically it is correct. But when we talk about semantically, the one that has to do with meaning, that statement, Emeka is a girl, is wrong. I hope you're getting what I'm saying. So the syntax and semantic phases handle large number of errors in compilation process. Error handler handles all types of errors, like I've mentioned some lexical errors, syntax errors, semantic errors, even logical errors. We also have compile time errors and runtime errors. Now let's go to automatic garbage collection. Now, to rely solely on garbage collection to free memories resources, I don't know. During when you are studying, I think that comes under operating system. Sometimes we talk about defragmentation of disk under operating system. We're actually trying to remove some unused places, or maybe match some unused places, or delete some of the patches and bring them together. Maybe bring used places together and bring all the unused places together, so that it can form, or it can contain, we can form a contiguous allocation where important data could be stored. So when we talk about here under compilation, we have what we call automatic garbage collection. There are sometimes you have maybe information, scattered, all in the memory. You can decide to push them together or remove the ones that are not needed, so that there could be spaces where important data could be stored. So garbage collection, we solely rely on garbage collection to free memory resources when not used anymore. Maybe you have used a particular memory to store something, and that data is no longer in use. Can decide to do what? To relinquish it or delete it, so that there could be spaces for other data to be stored. A regular claim is that this is a lot easier than having to do explicit free operations. Why that is true? Garbage collection still does not solve all the memory problems. Indeed, it does not solve all the memory problems, but at least it will solve these problems, to an extent. It can only work if all references to unused objects have actually been deleted by the programmer. If it has not been deleted, or maybe there are some programs that are still making use of such memory spaces, then it will not work. So it becomes much more, it is not much more trivial than placing explicit free operations. The two aspects that still make it a lot easier is that, unlike for free, the order of erasing pointers is less critical. Also, improper placement of reference erase operations like null, at least, does not corrupt memory access. So in garbage collection, we are actually talking about solving the storage reclamation problem for a system that allocates storage automatically from a heap and does not require the programmer to give any indication that particular items are no longer useful or accessible. A reference count scheme for reclaiming non-self referential structures and a linearizing compacting copying scheme to recognize all storage at the users. Hello? Hello?
Can hear you, I can hear you.
Okay. Automatic reclamation of storage no longer in use is done by two techniques. When we are talking about automatic garbage collector. Automatic reclamation of storage that are no longer in use can be done using two techniques. One is garbage collection. When storage fills up, the system traces starting from all data structures directly accessible to the programmer, marking these and all indirectly accessible structures as needing to be retained. Then all space not marked is reclaimed. All the space not marked is reclaimed. So you mark all those ones. Then the ones not marked can be reclaimed and be used for other, programs or other data. So the disadvantage of garbage collection is that the time it takes to collect and use space is proportional to the amount of space still in use, since that all must be traced, because you need to trace it now, go from one memory location to another in search of the ones that are no longer in use. Anyone that is not anyone that is in use is marked. Then the only one that is not in use is left unmarked. Then later you cannot collect all the ones that are locked. So you find that the time is even taking you to go from one distance to another is proportional to the amount of space. So that is one of the disadvantages of this garbage collection. The time it takes to collect unused space is proportional to the amount of space still in use, since that all must be traced. In addition, in an extended physical memory system, the garbage collector must access many pages on secondary store. And it's a very, very slow process. Finally, garbage collection is a completely disruptive process. Computation cannot proceed while it is in progress. When you are doing this, computation cannot go, that is, you cannot do other things simultaneously while garbage collection is taking place. So it is also an advantage. It's also a disadvantage. So another issue, we have said before that we have two things are involved. We have mentioned the first one, which is garbage collection, is one of the techniques. Then the second one is what we call reference counts. Reference counts. Each allocated datum keeps track of how many other data reference it. So when the count becomes 0, the datum can be reclaimed. Now, this scheme does not detect self-referential structures which are not accessible from the outside. Also, the reference count is often only the reference count is often only a few bits wide, and once it reaches its maximum value, it can never be decremented. So these properties require a garbage collector in addition to reference counting, garbage collection, and reference counting. Most inaccessible storage is picked up by the reference count going to 0, and thus garbage collections can be much less frequent and ensure maximum utilization of storage. Since the garbage collections are not needed often, the user can be given the choice, for choosing a convenient moment to initiate it, since you know that it does not go pari passu or simultaneously with other operations. So the chief attraction of the reference count scheme remains what we have just mentioned now. Then we'll go to static and runtime data representation. This one, this one has to do with data representation, representing characters, integers, floats, talking about beats, bytes, all those things. Maybe you must have refresh your memories on those ones. So these are some of the things you need to know. Then under static and time representation, we have simple variables. These are usually represented by sufficiently large memory locations to hold them. They include the characters that could range from 1 or 2 bytes. Then we have the integers, 2, 4, or 8 bytes. We have floating points data that will range from 4 to 16 bytes. So you can see that this one can occupy large memory locations. We also have booleans. Booleans is just 1 bit, yes or no, 1 or 0, true or false. So this one only occupy just 1 bit. Then characters, integers, booleans, and other integer family types are usually stored in a binary polynomial form with some mechanisms such as ones or twos, complements. I hope you're getting what I'm saying. Hello? Are you getting what I'm saying?
Yes, I'm getting you.
Okay. So these are just jot down some of these things. When you go, you read them up. You read them up because, oh God, we are running out of time. Okay. So we continue. We'll now go to storage allocation. This one involves 3 important tasks. One, it specifies the amount of memory required. Storage allocation is very, very crucial during compilation because those things that they are compiling must be stored in memories. So storage allocation is a crucial aspect of compilation. It involves 3 important tasks. The storage allocation involves 3 important tasks. One, it specifies the amount of memory required. It is a model to implement lifetime and scope. Again, it performs memory mapping to access non-scalar values. Scalar values like the stack. Of course, stack, you know that stack is a linear data structure that operates in LIFO format, last in, first out. And so this stack allocation and deallocation is done or are done in LIFO order. One entry accessible at a time through the top. That is the stack. That is the stack. Then we have what we call extended stack. Extended stack differs from a normal stack due to the following reasons. One, entries are of different size. It has 2 additional pointers. Record-based pointer points to first word of last record. First word in any record is a reserved pointer for housekeeping. The allocations involved in stack include the push operation and the pop operation. Push simply means you are adding to the stack, while pop operation means you are removing from the stack. So there are 2 methods of storage allocation. We have the static allocation and we have the dynamic allocation. Usually the garbage collection information are allocated statically. So dynamic allocation is performed during execution. Remember, static allocation, that is during the compilation, but dynamic allocation is performed during the execution. So there are 2 types of dynamic execution. We have the automatic dynamic allocation and program controlled dynamic allocation. In automatic dynamic allocation. Memory is allocated to the variables declared in a program unit when the program unit is entered during execution, and it is deallocated when the program unit is exited. Remember, automatic dynamic allocation uses the stack. Then the program controlled dynamic allocation execution at arbitrary points, and this uses a heap. They make use of heap as a data structure. Memory allocation in block structure include a block is a program, is a program segment that contains data declarations, and there can be nested blocks, and usually it uses dynamic talking about a program controlled dynamic allocation. They make use of a block, and they also nested blocks, and they use dynamic memory allocation. The memory allocation and access. We have memory allocation and access. Automatic memory allocation implemented or is implemented using extended stack model with variation. So each record is called an activation record, and it contains variables for one activation of block. So we mentioned a dynamic pointer, and we said that the first reserved pointer in activation record is called the dynamic pointer. It points to the activation record of its dynamic parent. Then we have static pointer, is the second reserved pointer in activation record, is called the static pointer. It points to the activation record of its static ancestor. A record can have any level of ancestors. Then we also have array allocation and access. A one-dimensional array can be allocated as a single sequence of contiguous locations. But for a two-dimensional array, it is not the case. Array elements can be arranged either in row major form or in column major form. So these are some of the things we need to learn. So these all that I've mentioned now is just a summary of what you should be expecting in this course from my own part. Just like I promised you, I will be sending some materials which I have found to be, crucial or important in these topics given to me. The topics include code generation and optimization, error detection and recovery, automatic garbage collection, static and runtime data representation, register and storage allocation. So I don't know if you have any question. And I want to take my attendance. Course rep.
Yes, ma'am.
Hello?
Yes.
You are just 3 persons. So write their names and forward to me on that platform. Is that clear? That these are the people that attended the virtual class. Just write their names and forward on the platform so I can record it. Okay?
It's okay.
Any question?
None from me.
Now, let me use this opportunity. Just like I promised, I'll be sending the materials to you on this course. Maybe some of that time when we have maybe physical class, can still ask some questions. Now, let me just touch the, what do you call it? The CSC 822. CSC 822. Computer graphics and image processing. Computer graphics and image processing. Okay, let me see if I can. computer graphics and image processing. Okay. Okay. Let me see. I have decided to, I will give you a summary, but I've decided to give you a, I've decided to give you the summary. Then you're expected to um, present a seminar on this topic. A seminar on this topic. Let me even see if I can. I'm coming.
But we have barely 30 seconds to go.
Okay. So let me see if I can. Okay. So what happens is that concerning the okay, let me just quickly show you that computer okay, introduction to computer graphics. We say that computer is an information processing machine. We know that, and that computer graphics is one of the most effective and common